My name's Darren Holmes, and this week we're working on Chapter 2 of the reference manual, Get Started with MicroPython on the Raspberry Pi Pico. So if you remember from last week, we downloaded the digital edition of the book. I also downloaded some Python documentation from python.org. We also downloaded the MicroPython interpreter for the Raspberry Pi Pico and installed it on our Pico. And while we were on the internet downloading things, I also got a copy of Thonny. So this week we're going to install Thonny and run it and run a few sample exercises. So I'm going to start by clicking on Thonny. And then to install it, I'm going to double click on it. So on this computer, I can install it for me only, or I can install it for all users. I'm the only user on this particular laptop, so I'm going to install for me only. So this is an install wizard. So I'm just going to click on Next. I believe you have to accept the agreement or else it will kick you out of the install. So I'm going to select Next. You might want to remember this directory. This is my directory that it's going to install it to. So I'm just going to leave it at the default and select Next. And I'm going to select Next again. It's always handy to have a desktop icon, so I'm going to check that box and select Next. It says it's now ready to install, so I'm going to click on the Install button. Okay, it says great success, so I'm just going to click on Finished. And now I'm going to minimize Windows Explorer. And you can see I have a new desktop icon. And it's called Thonny. So I'm just going to go ahead and double click on it. Now I'm just going to leave it in English and standard and say let's go. And this is what the Thonny IDE or Integrated Development Environment looks like. So at the top here I have a toolbar. It's a pretty standard toolbar. So if I go to File, you can see I have New, Open, Close, Save, or Exit the program. This area here is the scripting area. So when you're writing code for an interpreter, such as Python, they call it a script rather than a program. So this is where you actually write your program. So all the lines of code would be written in here. This is the Python shell area. Now when you're using an interpreter, you can actually write a line of code and the interpreter will execute that line of code. So rather than going through a whole line of code in your script, you can just try out one command at a time down here in the shell area. Now in the bottom right hand corner, this is your interpreter. So you can see it says Python 3.7.9. So if you click on that, you can see it says the same interpreter which runs Thonny by default. So that's the only interpreter you have access to at the moment. So what I'm going to do is I'm going to go ahead and I'm going to plug in my Raspberry Pi Pico. I'm not holding down the boot select button. I'm just plugging it in. And you could hear the little ding my computer made to say that it's plugged in. So now when I click on the interpreter, you can see I have several options here. So I can actually go ahead and select MicroPython on the Raspberry Pi Pico. So if you have your Raspberry Pi with you, you can plug it in and use MicroPython. If you don't have it with you, you can just use the default interpreter. So since I've just plugged mine in, I'm going to select MicroPython. So you can see at the bottom here, it says I'm now using MicroPython. So if you start Thonny without the Pico plugged in, you're going to get an error message saying couldn't find the device automatically. If you want to use the IDE without the Pico installed, just click down here on the interpreter and select default, and now you can use the IDE without the Pico plugged in. So when you plug your Pico in at a later time, you can then go back to the interpreter at the bottom right hand corner, and you can now select Raspberry Pi Pico. I want to go over a few terms with you. So I went to Wikipedia and I found out that Python is an interpreted high-level general-purpose programming language. So what does interpreted mean? So interpreter in computer science, an interpreter is a computer program that directly executes instructions written in a programming or scripting language without requiring them previously to have been compiled into machine language program. So what does compiled mean? In computing, a compiler is a computer program that translates computer code written in one programming language into another language. Normally it's from a higher level programming language to a lower level language like assembly language. So what is assembly language? So in computer programming, assembly language is sometimes abbreviated as ASM, is any low-level programming language in which there is a very strong correspondence between the instructions in the language and the architecture's machine code instructions. So looking at the assembly language example they gave us for a Motorola 6800, we can see the first set of digits here are actually an address location. The next digit, B6, refers to the LDA instruction. So if we come down the list here, we can see we have a jump instruction. The jump instruction is 7E, and we're jumping to a memory location. In this case, the memory location is C079. So in assembly language, you can see there's a direct correspondence between the instruction and what the actual machine needs to execute that instruction. So basically, the Python programming language takes each line of code and converts it into machine code when it's required, whereas a compiler would take the entire source code and convert the entire thing into machine executable code. This means that an interpreted language is going to be slower when it has to repeatedly execute the same instruction over and over again. So if you're following along in your textbook, you can see the next part is your first MicroPython program called Hello World. So what we're going to do is click on the Python shell area, so that's at the bottom, and we're going to type in this code and press enter and see what happens. So you can see here where it says MicroPython version 1.17, we have these little arrows here. So right where those little arrows are, just click. Now we're going to type in print. So this is a Python command, and it needs brackets or parentheses. And because we're going to be putting in string type data, so alphabetic characters are called strings. So we're going to put in hello and a comma followed by world. and it looks like they want an exclamation point. So we'll put that in. We have to close our quotes, and notice that the line changed to kind of indicate that the string data that we put in there has now stopped. And then we have to put our closing bracket. You notice it's no longer highlighted. So this is a function of the IDE. The IDE is set up for the Python programming language, and all that highlighting is to help you so that you know what kind of information you need to continue putting in so that you're finished. Okay, it says now to press enter. So you can see it's printed hello world exactly as we put it in up here. So we can type anything within those quotation marks that we like, and it will print it down here. So let's go ahead and try printing something else. So I'm going to say print, and there's my bracket, and there's my quotes, and I'm going to say hello class. And I'm going to use a decimal point and close my quotes and close my bracket and press enter. It seems I have an error message here. It says the name print isn't defined. You notice I used a capital P in my print, so I guess I'm supposed to use a small p. So I'm going to use a small p, R-I-N-T, my bracket, my quote, hello class, and press enter. Now you can see it says hello class. So when we make an error like this, it was expecting lowercase print, and we put a capital in there. This is called a syntax error. We're supposed to use lowercase p, and we used an uppercase P by accident. So when you make an error, an interpreter will come up and tell you where the error is. So looking back at our reference manual, you can see it does talk about syntax errors. So we've finished working in the shell area. Now we want to work in the scripting area where we're going to write longer code. So what I'm going to do is I'm actually going to highlight what we've just done here, do a right click copy, then come up here and do a right click paste. So that saved me typing all that in. Now watch what happens when I press enter. Absolutely nothing happens. So in order to run the code in the scripting area, we have to use the run command. So we can come up here to this little green circle that says run, or press F5, or we can come up to the tools and click on run. So I'm just going to click on this icon, and it's going to ask me to save the document. So you can see in the top left hand corner here where it says Thonny, it's untitled. So it obviously needs to save your file before it can run it. So we have the option of saving it to this computer or saving it to the Raspberry Pi Pico. Remember, we have about 17 meg of space on the Pico, so we might as well use that to store our program. So I'm going to click on Pico. Then we're going to give it a descriptive name. So the textbook uses hello world, so we'll use that here. You can use spaces. Some special characters you can't use. And we want an extension of .py so that we know it's Python code. Now there's a couple file names you can't use, and that's boot.py and main.py. These are special file names that we'll be using later. So I'm going to click on OK. So now you can see down here in the shell area, it's done a run. I don't know what the -c is for, but it's the editor content. So this scripting area is the editor content, and now we've run our program. So if I close down Thonny and then restart Thonny, if I come up here to File, I can say Open, and I can open from the Raspberry Pi Pico, and you'll notice there's the program I just saved. I can say OK, and it's brought it back up for me. So this is a handy feature. So the Pico has some advanced features. So if you want to take a look at what's actually on your Raspberry Pi, if you go to File Explorer, you'll notice there is no C drive equivalent for your Pico. So in order to take a look at what actually is stored on your Pico, we come down to the shell area and we type import OS and press enter. Now what we're going to do is go os.listdir and our brackets, press enter, and it gives us a listing of the programs that's available on our Raspberry Pi's built-in storage. If you're looking for some other commands, you can type in dir and in brackets os bracket enter. So these are the other commands that we can use. You'll notice there is a remove command. So if you wanted to actually delete this program that you've stored on your Python, you do that by saying os.remove, and then in brackets with a single little quote you could type in HELLO space world, and don't forget the .py, and close your bracket. Now one feature that we have in the shell area I haven't shown you before is if we want to get back and do a listing of what's available to us, so it's os.listdir and brackets. If you use the up arrow keys, it will find things that you've already typed in there. So once you've found the one you like, you can press enter, and you can see the file is now being deleted. So we're now moving on to the bottom of page 26 of our reference book here. Next steps, loops and code indentation. This is where we're going to control the flow of the program. So what we're going to do is we're going to create a new program. So we're going to click on New, and you can see we have our old program as well as our new program. So I've typed in the code as shown in the book, and when I press enter, you'll notice Thonny has automatically indented 4 spaces for me. So the for command is going to do something a certain number of times. In this case it should do something 10 times, and what it wants to know now is what I want it to do for 10 times. Okay, so I've typed in loop number I. So looking at my code right now, it says for I. Now I is a variable, and it's in the range of 10, so I'm expecting it to do something 10 times. And what it's going to do is print loop number and whatever is in that variable each time that it goes through this loop. Now when I press enter, you'll notice it continues to indent. So I no longer want it to indent, so I'm going to hit the back arrow or backspace, and it takes me back to the beginning, so it's now in line. So here I'm going to print the next command. So when I press enter, it comes back here right to the start. So this is what the code looks like at the end of page 27. So I'm going to come up here and I'm going to click run. Now it's going to ask me to save it because this is brand new and it's untitled. So I'm going to save it on the Raspberry Pi Pico. And I'm going to give it a new name. I'm just going to call it 4. And remember, it's .py. So you can see down here, it's printed what I asked it to print in here, followed by whatever was in that variable name I. So you can see it starts with loop starting, and it starts at 0. So you have to keep this in mind. When you say it's in a range of 10, it starts counting from 0 to 9, and then it says loop finished. So if I had put this print loop finished and indented it, so I'm just going to put the 4 spaces in there. Now if I run this code again, you can see it prints each of those numbers followed by a finished each time. So you have to be very careful how many spaces you put in before a command, because if you put in the 4 spaces, it thinks it's a part of the for statement. So you remember I showed you where to find Python documentation. So if I double click on it and go into the docs PDF directory, and I come down here to, I can go to reference or tutorial. So double clicking on tutorial brings up the Python tutorial, and in here we have a table of contents, and you can see the for statement is on page 19. You can see I can get additional information on the for statement. I can get information on range function. So now we're going to create an infinite loop. So we're going to change the for statement. So just go ahead and highlight the entire for statement and replace it with while true. Now keep in mind the true has a capital T in it. So if I try and run this right now, you'll see it says loop starting, which is the first line of code. And then all of a sudden I have a problem with line 3. It says the name I isn't defined. So I was a variable, and we were using it for the for statement, but with the while statement I isn't used. So what we're going to do is we're going to change loop number to loop running, and then we're going ahead and going to delete the comma and the I variable. So now we're going to try running this program again. Now keep in mind it's just going to keep running, so we're going to hit stop to stop it. So what's happened here is while true, well it's always true, so it just keeps printing loop running, while true, loop running, while true, loop running. So it never reaches the last statement, which is to print loop finished. So if you're using version 10 of the digital download of Get Started with MicroPython on the Raspberry Pi Pico, they've changed this example a little bit. They're saying to avoid the program running too quickly, we'll also add a short time delay by importing the uTime library at the start and adding a 1-second delay to the loop. So we're going to learn more about these libraries in later chapters, but for today we're just going to, at the start of our program, do an import uTime. And then within our loop, we're going to say uTime dot sleep 1 to give it a 1-second delay. So you can see I've already typed in my code. I have the import uTime. So these are the time library functions that are available to us. So within my while loop, you can see I'm going to use the sleep function in uTime, and I'm going to put it to sleep for 1 second. So let's go ahead and run this and see the result. So you can see the loop started, the loop running, and now we have a delay, so I can press stop, and it'll end our program. So you can see giving it that 1 second delay limits the amount of times that it prints out. So moving on to page 29, we're now going to start talking about conditionals and variables in a little more detail. So it says variables in MicroPython exist for more than just controlling loops. So variables are normally used for storing information. So in the script area, you can see I've typed in username. So username is my variable, and in it I'm going to store some kind of input. What is your name? So what is your name should display down here in the shell area, and it should wait for me to type something in because I'm using the input command. So let's go ahead and run this. You can see at the bottom here it says, what is your name? So I'm just going to type in my name and press enter. Now as you can see, it didn't do anything more than that. So all it's done so far is stored my name into the username variable. So I finished typing in the rest of the code. You can see we're starting to use an if statement. Now I want you to notice the difference between equal and equal equal. So equal is an assignment. So the input that I type goes into username. Down here I'm saying if the username is equal to. So equal to is equal equal. If you just put an equal there, it will put Clark Kent into username. So equal equal is testing to see if username is equal to Clark Kent. So let's save this and go ahead and run it. So you can see down here it's just sitting here waiting for me to type something. So I'm going to type in my name and press enter. And you can see my name was not equal to Clark Kent, so it printed, "You are not Superman." So the else statement works with the if statement. If this part is true, it's going to do this. Else, it's going to do this. So let's go ahead and run this again. And this time I'm going to put in Clark Kent. Remember, we're checking for capital C, Lark, capital K, Ent. So make sure you do have a capital C and a capital K. Then press enter. Here you can see it says you are Superman. So you can see here at the bottom of page 30, they do give you some information about using equal and using equal equal. And it says here, mixing them up is a sure way to end up with a program that doesn't work. Okay, so moving on, there's also another symbol in here. Instead of equal equal, you can use an exclamation point equal, which means not equal to. So it's the opposite of equal equal. So these are comparison operators. So you can use these in loops. So taking a look at their next example, we can see that they're going to be using a while loop. And in here we have while username is not equal to Clark Kent. So let's go ahead and type that into Thonny. Okay, so I've typed in the new program, And I just want you to note that up here where we have name test, there's a little asterisk there. That means it hasn't been saved in a while. So just go ahead and say File, Save, and you notice the little asterisk disappears. Now when we take a look at this code, username is a variable, and for the for statement we used I as the variable. I was being used to store a numerical value. Here, username is being used to store string type data. So when you see characters like this, it's string type data. The while statement is trying to check username against something. So here we're checking username is not equal to Clark Kent. We're going to print a statement saying you are not Superman. Try again. And notice we have to use username equals input. We need a second input statement. If we didn't use this first input statement, when it reached the while username is not equal to Clark Kent, username would not have a value to check for, and we'd get an error message. So you can see the while statement is using 2 lines. So when we have the situation where the username is equal to Clark Kent, it won't run those 2 lines. It'll print the last line, you are not Superman, and then stop the program. So let's go ahead and run this program. And you can see down here in the shell, it's waiting for you to type in something. So I'm going to type my name in and press enter. As expected, it says you are not Superman. Try again. What is your name? So now we're looking at this statement here. This is the input that we're looking at. The first input is this line. The second input is this line. This time I'm going to type my full name. It still says you are not Superman. Try again. So this input statement is still this input statement right here. So this time I'm going to type in Clark Kent. So now you can see when it checked username is not equal to Clark Kent. In this case it was equal to Clark Kent because that's what I typed in. The while loop ends and it prints the next statement after the while statement. So we covered a lot of material today. So I want to show you some reference materials. This is from W3 Schools. Their address is www.w3schools.com, and this website's all about learning to code. So if you just scroll down, they teach you HTML, CSS, JavaScript, and also Python. So if you click on Python reference, and make sure that you scroll all the way to the top here, they have Python tutorials, so getting started, syntax, comments, variables. So if you click on variables, it tells you something about creating variables. Variable names, it'll tell you what's acceptable. So a variable name must start with a letter or an underscore character, cannot start with a number. So these are all good things to know. Python operators. So this is basically math. So when you're talking math, you're talking plus, minus. Multiplication is the asterisk. Division is the slash. Assignment operators. And these are the comparison operators. So you notice there's the two equal signs being equal, the exclamation point equal being not equal. The Python if-else statement. So you can see the checking here, equal, not equal. In here they give an example. If B is greater than A, we can do a print. We don't have to use the else statement. We have the elif. So if B is greater than A, print B is greater than A. If A is equal to B, print A and B are equal. And the else statement. We have the Python while loops. So in here they show you how to use the while loop. We can also click on the for loop. So it gives you an example of using the for loop. As you scroll further down, you'll come to the Python reference. One of the things I want to show you is Python keywords. So Python has a set of keywords that are reserved words that cannot be used as variable names, function names, or any other identifiers. So when we take a look at these reserved words, you'll notice some of them. There's false, there's else, there's for, there's if, there's true, and there's while. So these are names that you cannot use for your variables. But you notice most of them are commands that we use in Python. So the last thing I want to mention is Python data types. So we have some built-in data types. So these are important when you're kind of storing information into variables. So we have the text type, which is string. We have numerical information. So we have integer, floating point, and complex. And we also have something called Boolean types. So these are your true and falses. So I hope you'll find this website useful to you. It's w3schools.com. So please make sure you actually go through Chapter 2, reread it, and go through all the examples again so that you can familiarize yourself with some of the Python commands that we've used in Chapter 2. So this concludes our video on Chapter 2. In our next video, we'll be in Chapter 3, Physical Computing, and we'll be learning all about the pins on our Raspberry Pi Pico. So please don't forget to subscribe, and we'll see you on the next video.